All right, so in this video, I'm going to show you how to complete a proof. Now, this isn't a full proof because we're going to be filling the blanks. You can actually see a little bit of blank filled in there, so I'll have to fix that. It's because I clicked the button. So with this one, it says, use the given information to complete the proof and the following theorem. If opposite sides of a quadrilateral are congruent, then it is a parallelogram. So we're proving this statement. Now, if you've been following along in this chapter, you already know this is true. If we have a parallelogram, then the opposite sides are congruent. So if we have opposite sides of quadrilateral congruent, then we automatically go, oh, well, then it must be a parallelogram, right? So by definition, a parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. Use this in your definition. So we're going to use the definition of a parallelogram. So let's go through. And what you want to do on a proof is, proofs are a little bit different because now what you're doing is you're going through and you're working through your problem, but you also have to stop and say, why? How do I know that I can do that? Okay? So the first thing, and this is what I always do, whenever I look at the diagram, number one, I draw it and I label it so that I don't have to keep track of all that information in my head. I can actually keep track of it on the diagram. If it's given to me, those are usually the first things I put in my proof. If you haven't put it in your proof, it doesn't exist. Okay, so make sure that even though it's given, you have to put it down here, and your reason that you put it down here is that it was given to you. Okay, so the first thing they give us is QR is congruent to ST. So that is my first given. So you can see I've marked my diagram here. So I have the sides that show me, and it's down here as a statement and a reason. I put it in my proof because it was given to me. Otherwise, I wouldn't necessarily know that this was true. The second thing they gave me was QT is congruent to RS. So now I know that piece of information. So I have it marked. I like using different colors. You can also use tick marks. That's definitely a very common way of doing that. So now what I want to do is I want to look at this third side here. There's a third side that they're sharing. And they're telling me they're using the reflex property, which means that I'm going to look at what something equal to itself. So the only thing on here that's equal to itself, if I split the triangle, I have this one on the right, one on the left, and this one on the right, is this RT. They both share this length. So RT is going to be congruent to RT. It's congruent to itself. Whenever you have a shared side like that, you're probably going to use reflex. It's a pretty good guarantee. So now the fourth step that's on here, they want us to fill this one in, and they want us to give the reason. So now we have triangle QRT is congruent to triangle STR. And this is going back to when we were doing triangles that are congruent to each other. I have three sides of this one on the left congruent to this three sides of this one on the right. So the three sides are congruent to each other from triangle to triangle. So this is side, side, side congruence. So now that I know that the sides are congruent to each other and the triangles are congruent, we can use this property called CPCTC, which is corresponding parts of congruent triangles are congruent. Okay? So it's a shorter way of saying it, CPCTC. So the corresponding parts means that I have to match them up. So 1 corresponds to 4 and 2 corresponds to 3. So we can see this down here. 1 corresponds to 4 and 2 corresponds to 3. So I kind of have to flip this triangle around to make sure, because I can see this, if it's going from blue to pink here, well, I want to do the same thing, blue to pink here. So, and that started with the angle 1, that started with the angle 4, so I can kind of do it that way and kind of see that they match. Or here, I'm starting from the red-pink corner, going over to the blue line, red-pink corner going over the blue line, so I started on angle 3, I started on angle 2. So 3 and 2 are corresponding. They're kind of in the same relative position. Okay, so we're using corresponding parts of congruent triangles are congruent. So now that I know that angle 1 is congruent to angle 4 and angle 2 is congruent to angle 3, well, now I can go back to when we learned about parallel lines, because if angle 2 is congruent to angle 3, then they're alternate interior angles, and that proves that QT is parallel to RS. And the same thing with angle 1 and 4. Since they're alternate interior angles, that proves that RQ is parallel to ST. So that's in fact what we're going to do here. So RQ is parallel to ST. The bottom is parallel to the top because of alternate interior angles. So if alternate interior angles are congruent, then the lines are parallel. And same thing with QT. So QT is parallel to RS. Oh, I was talking about the bottom of the top for the step 7. That was the left and the right side. Silly me. But same reason. If alternate interior angles are congruent, then the lines are parallel. So this is kind of stepping back to when we learned about triangles, when we learned about alternate interior angles. This is going back to the first semester. Okay. So now that I know that opposite sides are parallel, that QRST for my quadrilateral is a parallelogram by definition. So with this one, if opposite sides of quadrilateral are congruent, then it is parallel. Sometimes you can also choose definition of a parallelogram. That would also work if they have that in the drop-down menu. So this is completing a proof of a parallelogram. I hope that helped, and I will see you in the next video.